It's a very neat idea. I mean, of course, the problem, obviously, is it's only one pair. It's a very small sample, but I mean, in reality, how are you going to fund multiple pairs? So, but to me, it's probably what I like about it is it's a nice illustrative project more than that it will actually deliver great scientific value. I mean, obviously, it can only sort of be at an anecdotal level, really. But I still think it's worth doing, and it's an illustration of what we call the MZ co-twin control study. So that's the same idea.
Yeah.
So we took 100 pairs of twins in Sydney. This was in about 1982. We did this study at the beginning of winter. Then we analysed the cold symptoms by what they thought they were getting. And if you did that, there was a huge effect.
Yeah.
Absolutely huge effect. The only trouble is if you then did a 2x2 analysis of what they thought they were getting against what they were actually getting, that was completely random. There was no relationship at all. So it just goes to show the power of the placebo effect. Yeah.
Back to the Kelly brothers, that I guess relationship to, I guess it's a bit confusing to understand how that relationship will affect genetics.
Well, you see, what it's doing is taking advantage of the fact that, it's not telling you anything about the genetics of the condition. What it's doing is taking advantage of the fact that they're genetically identical to then look at a contrasting environment that they're in to see the effect of the environment. So the problem is if you just go out and say you test the health of a bunch of astronauts with a bunch of people, say, on the ground, well, you find huge differences. But the first, there are many things that could be different, but an obvious one as well, maybe the astronauts were genetically different, which is not surprising since they've got to be super fit and, have very, very, focused personalities and so on, so they're very stable personalities, and, astronauts are not a random sample of the population by any means. And so, the whole principle is that you're actually getting people who are genetically identical and putting them in two different environments. The same as we did with the vitamin C, we're getting people genetically identical, one gets the vitamin C, one doesn't. And there's an earlier study doing the same thing with salt. There was this whole debate about salt and blood pressure. So they've got twins on high salt and low salt diets and so on. Virtually all of these studies, when you do it, find no effect of the environment.
Do you have any predictions for this one? Same as the vitamin C, perhaps?
No, but this is all looking at all those things they look at in space medicine. I can't remember what they are.
But surely they're so different environment, it's hard to compare them in any case. Like space in an isolated, you've got other conflicting factors, surely.
No, but that's the whole point. The whole
that's
point is
also looking at isolation and.
But the question is, what are the effects of the space environment, whether it be the physical weightlessness or the isolation or whatever? They're not going to be able to deconfound those. The way to deconfound those would be to get triplets, identical triplets, which exist. We've actually got several sets in our studies, and stick one of them is on a space station, one of them in an isolation thing on the ground.
Yeah, because that's different
which
too.
exists. They actually have those things to test people out for fitness for being in space, to see if they can cope with that aspect, and then have one living a normal life. And then you could actually dissect that out. But you're right, at the moment this will confound the isolation aspect with the weightlessness aspect.